So say we are calculating the limit of this expression at -3. So here you can see the limit would be -3 plus 1, the absolute value. That is going to be absolute value of -2, that is 2. And over here, of course, this is not defined at x equals 0, but here we are looking at the limit at -3. So we just have to put that limit over. So what we get here is, for the limit, so we get the limit would be 2 minus 1, that is 1. So limit of this expression that we were trying to evaluate is simply going to be 1. And if we want, we can just go ahead and verify it graphically. So we are going to just graphically verify our answer. So I'm just going to type in this absolute value of x minus 1 plus 3 over x, and you can see right here that the limit is, so at -3 we got the limit as 1. And just notice for our future study that at -1 you can see a corner here. That means that the function is not differentiable. That's one of the upcoming attractions. Now again, let's take a similar example. That is, we have to compute the limit of this quantity at 5, and you can see at, in an interval containing x equals 5, the quantity is well defined, and the limit of the denominator is how much? Simply 6 times 5 minus 3, that is 27. So this limit simply will be, okay, 5 being substituted for x. So this simply becomes, the numerator you can calculate is 64, and the denominator is how much? 27. So the limit is simply that quotient, the cube root of 64 being 4, divided by the cube root of 27 is 3. So that's our limit here at 5. Now let's look at this example. So here what we have is this, that we have to get the limit as x goes to infinity of the difference between these two quantities. So if we did this, that if we looked at this, what you notice is this, that both the parts, this part goes to infinity and so does this, right? So it becomes of infinity minus infinity form, right? So in such cases, remember this, what generally helps is, that is, if we just went ahead and say rationalize the quantity by, how do we do that? We go ahead and multiply and divide by let's call it conjugate, nothing wrong in doing that. So just replace this negative sign by positive sign, and let's just go ahead and compensate for that here. Now what will happen now is that this is like a minus b times a plus b equals a square minus b square. So what you have here is then that you got this product as square of this quantity, right, minus square of this quantity here. Okay, so let me just bring it in here, and then when we do that, what we get is that we simply get, a square root will be just, a square root will just go away. Okay, so what we get is that here we get this, the quantity here, and in this case what we shall have, we shall simply have x square plus x and this is going to become how much? X square and x square will cancel. So in the numerator we will have only how much? Let me just bring it down here. In the numerator we will have only x, right? Now what we can do is this, that is now it is in the infinity over infinity form, right? So we may again, go further algebraically. So such as we can just pull out a square root of x square out. So what happens? This will be 1 and this is going to be 2 over x, right? And here also we got the same thing out, and you must have gone ahead of me, I suspect, and hope to. So here this is 1 over x. Now square root of x square is how much? That is simply absolute value of x, and I can do this, that is just factor that absolute value of x out. So let me do that here. So we got this, and here we simply got a square root of x square, that is absolute value of x. Now since x is going to positive infinity, so what will happen? X can be treated as a positive quantity, so we have simply x over here and they cancel, right? I forgot writing the limits here. So x and x will cancel, and what we get then is we simply have, okay, after the cancellation of x, we just got 1 here, and this would be 2 over x will go to 0, and so will 1 over x. So the value finally will be how much? 1 over 1 plus 1, that is simply 1/2. So the limit of the expression that we wanted is 1 over 2, or 1/2 again. Now let's look at a different situation in the context of the same expression, that this time instead of x going to infinity, we are letting x go to negative infinity. So what will happen here is, if we look at the two quantities like this one, you can factor an x out. So it's x times x plus 2, and both of them are going to negative infinity, so the product will go to infinity. And in the similar manner, this quantity will also go to infinity. So again we have an infinity minus infinity form as before. Okay, let's call it form, and so we will have to just work with some other method. Now looking at this, if you examine every step before, we have everything here going the same way as it did for positive infinity, right? Now the difference would be this, that absolute value of x for negative, absolute value of x when the values of x are negative, what that would be? That will be simply negative x, right? So this is going to become then, when you cancel the x's, so you have negative signs, right? And even when these guys go to negative infinity, these will go to 0. So our answer here would be what? Instead of positive 1 over 2, we shall simply have negative 1 over 2. And we can go ahead and verify it graphically. So here we have a graph of the expression that we were looking at, and you can see that as we go to right hand side further and further, the limits are close to 0.5 or 1/2, or these are horizontal asymptotes of the function. And at the same time, we may also, just keep this in mind, that we have this, that negative 2 to 0, they are not in the domain of this function. We have to have the values less than -2. What I mean to say is this, that this part -2, 0, that's not included in the domain of the function, and you can see that this is not in the graph. All right.